This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 87, we learn about Rocky DEM and take a look at what is happening in the world of Ansys. Welcome to our little podcast. I'm Eric Miller, one of the owners here at PADT, and your host for these get-togethers. Hopefully, some of you are able to attend Simulation World, which happened last week. It was another great event. The presentations from key Ansys people, including the CEO and CTO, helped us understand where Ansys is headed. And then there were just tons of great customer presentations, so many good examples of using Ansys tools on real-world problems in so many different areas. If you did miss it or didn't catch all of it, you can watch all the recordings at simulationworld.com, same site. Just go there and either register or use your email if you've registered already. And they'll be up for a little bit. There's some good stuff in there. Check it out. We want to recommend 3 presentations that we really liked. 2 of them were customers, and one of them was our very own Matt Sutton. So we're a little biased, but we do want to highlight them and point them out. The first one is from a former employee who's now the director of the Arizona State University Luminosity Lab. His name is Tyler Smith, and then he was with a student researcher named Connor Nail. And they basically were awarded funding from NASA to develop a system for exploration of the permanently shadowed areas on the lunar poles. And they're using Ansys tools to design their Variable Exploratory Lunar Observatory System, or VELOS. And their talk is about how they used Ansys to make that possible. So check that out. It's always good to see academia using the tools, and the fact that it was a former PADT employee was excellent to see as well. The second one we want to point out is from Los Alamos National Labs, and it's called Predictive Lung Modeling and Experimentation in a COVID World. So it's a multidisciplinary team at Los Alamos, and they used a bunch of different engineering approaches to characterize the means to improve oxygen delivery in lungs through mucus removal and drug delivery. So they used experiments and numerical analysis in tandem to characterize and predict the lungs' behavior. So, lungs are pretty complicated things, lots of branching, lots of tiny little passages. It's a really great use of Ansys CFD capabilities, and a really applicable one as well. So do check that recording out. And finally, Matt's been on this podcast before, Matt Sutton. He is our expert on ACT extensions for Ansys, and he talked about a tool that he worked on to help us out to convert Ansys results, Ansys mechanical results, into a 3MF file, which is a 3D printable file for additive manufacturing. And it's not only cool to understand how to make a plot using 3D print your results, but also a great example of how to write an ACT extension. So that one is a really good one, and I hope to convert that into a blog post at some point as well. So browse around. These are the 3 that were related to us, but there's probably a whole bunch of other stuff. If you're interested in something, whether it's a technology or an industry, there's probably a talk about it there. I also, before we get into the interview, want to reach out, take a moment to reach out to our listeners in India and Latin America. We cannot imagine the stress and worry you must have for your families and yourselves as the COVID-19 numbers keep climbing. I'm recording this on May 2nd, and the numbers just aren't great. We hope that you and yours are safe, positive thoughts headed your way, and we hope those numbers start coming down soon. I don't know about all of you everywhere listening, but I thought I was done with this pandemic, and then something else happens, and I'm done again. And as we say here at PADT, all we can do is stay smart, safe, and healthy, and then productive. So our interview, interestingly enough, is with a code called Rocky DEM, which is written by the channel partner in Latin America, ESSS. So we're going back a few months. We actually did this interview before they announced their partnership with Ansys, and then we meant to play it sooner, but we kept on getting other things we needed to talk about on the podcast. So now we finally made room for it, and I'll let them explain what Rocky DEM is and what it does.
Welcome, everybody, to a discussion I've really been looking forward to for some time. We're here to talk about a product called Rocky DEM, and we've got some folks from ESSS, as well as Robert McCathren from PADT, to talk about this exciting tool that is basically for modeling discrete particles. And that's probably not an accurate description. That's one of the first things we're going to talk about. But before we do that, why don't we go ahead and introduce yourselves? Marcus, why don't you tell us about yourself, and for people who don't know ESSS, what ESSS is all about.
Yeah, thanks, Eric. So I'm Marcus Reis. I'm responsible for sales and strategy of ESSS. ESSS is an Ansys partner in Latin America, in Iberia, but it's also a software development house. We have been developing a code for the oil and gas industry over the last, 20, 25 years. And more recently, close to 6-7 years, we have been working on the development and the implementation of Rocky DEM, which is this, the discrete element tool that we're going to talk about.
Very cool. And Ahmed, many of our listeners may know you from your lifetime with Fluent and Ansys. Why don't you tell us more about yourself and what you do with Rocky?
Thanks, Eric. So I've recently taken a position with ESSS, which I have been working with the folks there for, over 15, 20 years. Our relationship goes back to early days when we were trying to build a process industry and energy market in South America and eventually globally. But more recently, I have joined Rocky because I'm excited about what's happening around particle modeling and advancements in particle technology. So officially, I'm holding a position of basically a director level, and I'm functionally responsible for product strategy and business development, include sales and marketing with Rocky DEM.
Awesome. And then Robert?
Yeah, I'm Rob McCathren. I've been a application engineer over here at PADT for about 2 years, and a little over 2 years. And prior to that, I worked in the kind of offshore oil and gas and maritime industries as a structural engineer using Ansys pretty much the whole time.
Very cool. And a frequent visitor to our podcast, and we always like your insight on this. So feel free to jump in and ask questions. We're here at PADT. We're familiar with these tools, with Rocky especially, but haven't dug into it as much. I guess that's a pun, as we probably should. And one of the ways we wanted to start learning more is to have these folks on the podcast so you can learn along with us. So Marcus, why don't you just give us a very high level? What is just the discrete element method itself? How is it different from FEA, et cetera?
Yeah, it's of course it's a discrete method, as you said. FEA and CFD basically are based on, it's a continuous method. You solve an equation in a domain, right? DEM, it's a very first principle physics method that actually you solve Newton's second law. Okay, for each particle. Okay, so you treat each particle as an individual, and you track, the motion and the contacts and particle boundary, and you add physics into that. The forces, cohesion, adhesion, and you try to predict, the flow of the particles. So I usually say that you have, for example, when you approach a problem using a CFD tool like Fluent, you are solving a problem that is fluid dominated. So the fluid forces and the Navier-Stokes equations, they are ones that decide the game there, right? Sometimes you have problems that are particle dominated, okay? And usually, this discrete element method is being a good approach to try to model the behavior, of the particles.
Yeah, and it's not just big particles. So I always think of it as ping pong balls, right? And we can write the equation for a ping pong ball and how it hits each other and things like that. But it doesn't have to be a perfect sphere, correct? And it can be quite small, where you get these things like adhesion going on, right?
Yeah, and that's a very good point, Eric. And particles are everywhere. Okay, you can treat particles as potato chips, hair, hay, fibers, grass, blood cells, biomass pellets, iron ore, and things like that. So it's a growing field because you are looking not only on the design of new equipment and how that equipment will interact with particles or will move particles from point A to point B, but you're also looking at different applications inside the industry, like production process, for example, where you have to prepare raw material to mix that, and then separate, and then let's say mold that or fill a cavity. I don't know. So that's particles are everywhere, and that's the key message. And they can have different sizes and shapes, different physics. They can be under fluid flow. They can be under electromagnetic force, and things like that. So it's very broad the terms of in terms of application and industry presence.
So Eric, if I could
go ahead,
add
please.
to Marcus's point, if you think about historically when we did computational fluid mechanics, when particles were involved, we assumed particles are dilute phase, and we really missed the interaction between the different particles. So this is the old DPM models and all that. Right. Then eventually we start solving two fluid equations, and we account for bulk solids presence, usually with it one size or maybe two sizes, and then we solve the momentum equation with that, and then we use drag laws between the particles and the fluids. What is unique about the DEM method is that we actually are interested on particle dynamics, as Marcus said, particle hitting each other, as well as particle with the equipment or solids or surrounding boundaries and all that. So the beauty of it is we track in the particles, and here I wanted to emphasize what Marcus is saying. Particles right away, we assume spherical particles, but effectively we're talking about solid laden applications, right? So, and I'm sure we can talk about additional detail of how we deal with it, but I wanted to paint this picture that we're not thinking about particles as tiny little spheres. We just think about application when there are solids in of interest for us.
Lots of solids. Yeah. So computationally, is it? I know it depends on the problem and all the physics involved, but is it like more computationally intensive than CFD? About the same, less? Is this something I need a big computer for, or is it something I can run on my desktop?
It's all about the number of particles and the number of contacts that you have in your domain. Of course, you can have 100 million nodes FD problem. You can compare a 1,000 particle DM problem. Might not be the right way to do, but we usually I have, let's say, we usually try to solve a problem within 24 hours. Okay. If you take longer than that, it's probably it's more R&D than product design or process improvement. And as a rule of thumb, I would say that of course it depends on the problem side, but it's usually longer than an FEA. Let's say classic steady state thermal structural mechanics problem. And it's usually, faster than a pretty complex, big mesh, CFD problem. Okay, we are somehow in the middle, but of course it depends on the problem side, the number of particles, contacts, and the hardware available.
Right. And so I guess the big takeaway is you shouldn't be afraid from a computational need standpoint to solve these problems. You're not going to have to go out and get a supercluster to do it. This is feasible these today, which is great. So nice. So our experience at PADT with modeling particles is over 10 years old, and it was a coffee bean roaster, a unique centripetal device that roasted coffee beans in a faster way. And we're trying to contact the inventor to see if he'll let us remodel it with you guys in Rocky DEM. So that'll be an interesting thing. We did an LS Dyna back then. And it was really slow. So I'm excited to try these new tools. So that kind of one of the reasons why we're having this kind of laying the background there. One of the reasons why we're having this conversation now, although we've been interested in Rocky DEM for some time, is there's when this comes out, the announcement will have been made, a new relationship with Ansys. Do you want to share with us what that relationship is and how it impacts Ansys users out there?
Yes, this is exciting news. We have been teaming up with Ansys for, I'd say 3 to 4 years on the integration, with Ansys platform and Ansys Workbench. So Rocky on the technical side is integrated, as a Workbench component.
Great.
So it means that we are inside Workbench as the CFD products are, it means that, our Rocky input and output parameters are part of the Workbench, and Workbench, can handle that. So it can connect, with the mechanical solver, with the CFD solver. You can play with Design Explorer or OptiSlang, just to give you an idea. So as a result of this integration that we are working, we saw a market opportunity. We saw a lot of requests coming from Ansys customer base. Ansys look at that, saw that as a, an interesting and growing field. And decided to sign an agreement with us that we are packaging Rocky and some modules as Ansys Rocky. So
nice.
It's definitely a new Ansys product that will be available on the Ansys price list for both direct and channel partners to sell worldwide.
So you can get it from whoever you get your Ansys from today. I assume they'll be your first line of support with you guys backing them up for anything that they can't answer themselves.
That's the idea as a regular Ansys product.
Yep. Just anything else. But that's fantastic news and so much easier to deal with, and we don't have to learn a new tool, right? Because we can use mechanical, and I'm excited about that. It's I think it's going to be make it a lot easier for people to get access to the product. Is this going to be available with elastic currency? Do you know?
There's a plan for that, not at this stage. At this stage,
Okay.
We are hurrying up to be on the price list, to streamline, the licensing and order processing, marketing, and of course, sales and technical enablement.
Yeah. There's a lot to go in place there. We're excited about being closer on this. It's going to make it a lot easier. And I want to come back and at the end we'll talk about how people can learn more. But what I really want to get to is for you guys to share some customer success stories, if you're aware. Just what's your, I don't know, Marcus, what's your favorite application that was kind of a surprise to you that that you were like, oh, that's pretty cool that somebody's done with the tool?
Yeah, of course. As we consider, then, and it's working with Rocky DEM, it's been quite exciting because, of course, you mentioned the coffee roaster. We have been, modeling that with coffee beans, and fluent and heat and mass transfer, and analyzing, the temperatures and the velocities. But by far, the most interesting one is when we apply our, 1D particle model coupled with CFD, and we call our 1D particle as fibers. Okay, so let's say when we have the fiber model, and we did use that with one of our customers, B-Cell Home Care, and there's a success case and a press release out of that, and where they model the vacuum cleaner. Okay, inside the vacuum cleaner is actually a cyclone, where we are modeling, that being applied to actually, to model the pet hair going through the cyclone and getting, accumulated, and deposit at the bottom of the cyclone, and the clean air, moving to the exit, at the exit to the exit of the cyclone. So that was, modeling pet hair is one of the most, let's say, fascinating ones. Let me put it.
Yes, I looked down at my floor with a clump of it under my desk. Yes, that is very cool.
I was going to add a sweet example. As you know, many of the candies have these coating on them.
Mm-hmm.
And one of the nice applications of Rocky DEM is dealing with, uniformity of products and quality of the product. And so when the people spray coat candies, how well that's sprayed on. So the next time you have a piece of, skillet or M&M or whatever product maybe of your interest, if it's coated, most probably the whole process can be modeled with Rocky DEM and show the uniformity of the, in this case, candy being coated with different colors.
So that's really important, because when you said candy, I imagine, say, the bagging process for the candy, right? Once it's been coated and dried, you're going to put it into the bag, right? But you're saying the actual coating process you can model with Rocky DEM.
It does, yes. In fact, the whole spraying and the tumbling, right, and all that. So it could be with the heat transfer or without evaporation of the coating material. So that's one of the nice things, that the Rocky can be used alone. And as soon as the fluid becomes important, then you could decide the degree of fluid, importance of the fluid, so you could add fluent to it. And then so it would be a couple fluent Rocky calculation. Or if there is other application, maybe Ansys and mechanical with Rocky. So for a spray coating of candy, it's fluent and Rocky or Rocky alone.
Very cool. I didn't even think about that. That's a very a good example that we can all relate to. So next time you pick up an M&M, think of that. What about one of the industries that we're interested in it for, because it's kind of big here in Arizona, and I think it's true as well down in Latin America, is mining. Are you seeing a lot of application in that space as well?
Yeah. Well, the code was named Rocky because it was originally developed to model rock breakage.
Okay.
Right. Which is primarily in mining you have let's say three main process. If I want to make it very simple, okay, it's more than that, but you have to move particles from point A to point B, rocks, and we do that to transfer chutes, through belts and things like that, right? So you can model that. Okay. The second is that you need to reduce the particle size because you get larger rocks, and at the end you want to transport to to your customer smaller rocks, so you have to break them to reduce the particle size. So our code Rocky can be used to model the rocky breakage through a lot of crushers. Okay. So we are deep into the comminution industry. And the other one is separating. Okay. You need, of course, to separate the large ones from the small ones, so use screeners and things like that. So this is all these applications that involve particles, which are, I would say, it's not only mining, it's mining, metals, cement industry. Right. DM is widely used, say all the key players within this industry, they are familiar or they're using or they want to use a code like that because it helps them to improve their process, to avoid issues on the production side, and also the suppliers to increase and to predict, for example, wear, because everything that you are dealing with rocks, right, it's ended up suffering a little bit, right? So it helps you to let me jump into the structural analysis, for example. Right. At the beginning, where you're designing equipment, you're just applying that, let's assume that rocks are falling here. Let's put like 10 kilonewtons uniform, force here, or 10,000 pascals here as a pressure. With Rocky and Ansys, you can, within the mining industry, try to predict an accurate, let's say, load representation, spatial and also transient. That is, it's being applied at the surface of your structural design, for example. So you can do all this type of analysis within the mining industry, and it's, of course, a big sector for Rocky.
That's a really good point. Again, expanding my mind a little bit about the product is, you may not really care what happens to the particles, but the behavior of those particles may be a load for another analysis. And I'm actually thinking of one of our mining customers that makes augers for crushing. Probably way over designed because they don't really know what the load is, but being able to model the particles, they can get a more accurate load and maybe take some weight out of it and some cost out of it. So that'd be a great example. Yeah.
Eric, just to expand on that,
Yeah.
the energy saving, if
Mhm.
you don't have to over design these things, as
Yeah.
you know, moving these solids is quite energy intensive. So you're making a very good point there about additional cost saving by reducing the load. And staying with that example, one of the things that people can do with Rocky is actually modeling the wear on the equipment itself. So
Right.
and
Very
that
important.
could reduce the cost of the lining replacement, shutdown for maintenance, and all the thing that the classical things we know from the value simulation. Rocky can actually help with the wear modeling in this heavy equipment and moving solids.
Yeah, and I'm going to ask you about another industry totally unrelated that so one of the things that's come up when I talk about Rocky DEM with other people is all the simulations we've said no to over the years because we couldn't do them without a DEM tool, right? And one of them is the ability to model sand wedges for golfing. Have you guys had anybody look at that yet?
I think I'm going to come there and run some practices.
We've got the right customer for you.
We could do snow if that helps. So there is no reason, as you know, probably seen some simulation of LS Dyna and maybe other folks with that. There is no reason in Rocky you could actually model the movement of the solids. And movement of solid bodies. So there is no limitation on moving a golf club and actually calculate the contact between the golf club and the sand, right? Yep. So the fact that there is solid rigid body motion in Rocky allows you to do that problem altogether. So, but of course, we're talking about fine particles and how the sand is packed together and all those things. So that would be a fun thing to come and run some experiments in Arizona.
Yeah, it's a good testing, and we have a lot of data on that because they've been doing it through testing, understanding that through testing. I suck at golfing, so I have no understanding why anybody would care, but I guess it's a big deal how the sand goes over and under the club as the ball goes. So we look forward to exploring that as well. And then, of course, I'm sure there's aerospace applications out there where we're dealing with particles as well. So I don't think we should rule out any industry at all.
No, absolutely. On the aerospace, for example, we were discussing with a customer the other day, when they launch, rockets, there are a lot of debris,
yes.
That rapidly, comes down and you want to track them, and, they cannot be treated as only, spheres or Lagrangian particles because they have shapes, right? And one of the things that that keep Rocky apart from others is that we handle shapes, and because of the handle shapes, when we couple that with Fluent, we have drag laws that take shapes into account. So it's the one-way or two-way coupling. We take that factor, so we know if the particle is in line or not with the flow. So a square particle might have a different drag than a spherical one or a triangular shape one. So we take that into account. So we were discussing, this application with one, aerospace customer in the US the other day.
Good. And, inlet particle separators, there's so many different areas where we're shoveling sand or trying to avoid particles getting in and around things. So I'm excited about learning that.
Yeah. For example, Eric, sorry to interrupt, not only in aerospace, but in automotive, for example, debris accumulation, especially on all-terrain vehicles, that go through, mud, rocks, hay fields. You can track the trajectory of these particles and see, for example, if they're going to be accumulated near, let's say, more hot areas, or near the engine, and they might be, prone to have, let's say a fire incident, for example. So you can design not only the underhood or the aerodynamics of that, but taking large particles into account and how they accumulate around certain areas and regions of your design. So that's a key point. And the other day in automotive as well, we were using a DM for a customer in Japan that we're trying to model the snow, falling the windshield. And we actually have to add special, forces to take into account, the turbulent fluctuations, because that it really affects the snow, accumulation. There is no accretion process on the windshield or on the surface of the car. So that, as I said, everything can be seen as a particle. If you want to increase, the fidelity, if the physics, the particle-particle contact, the particle shape that are relevant, Rocky is, can be a good candidate to help you to increase the accuracy of your model.
Definitely. Yeah, we could probably talk all day for all the different applications on this, because I keep on thinking about new and exciting ways to use it. But we'll save that for the future. And for I'm sure you guys will continue to put out information about applications, which brings me to really where I want to sum things up, which is, where can they go to learn more? What's the best place to learn more about Rocky DEM?
So maybe I could pick up the first portion of this and give it to Marcus. So as you were talking about examples, they're really a great set of collection of videos in a Rocky YouTube channel.
Okay.
So it's youtube.com users/Rocky DEM simulator. There is all sort of videos. The latest thing actually shows a toothbrush and working on cleaning teeth. So I think going to the YouTube and looking at the Rocky videos would be a great place to extend our conversation about the range of applications. Marcus, do you want to add more to it?
Yeah, our website is quite complete. We have case studies. We have a technical library, where you can see webinars, ebooks, papers, white papers, kits, and of course there's a blog where we ask people to talk about different things every month, pretty much. So you're gonna see a lot of oil and gas examples, pharmaceutical examples, energy examples, and things like that. So it's a good resource. So the website and the YouTube are key for you to have access to that information.
And what is the website, just so people know?
Is www.rocky/dem.com.
Okay, very good. And we'll make sure we put that in the notes as well. But we all search anyway. I spent some fun time watching the simulations on the YouTube channel. It's pretty impressive, and it does spur on there's so many different applications I didn't think about. It does spur on thinking about how you can use it in different ways. And it's just yet another way to drive your design with simulation, right? With more accuracy, and fitting into the best part of Rocky DEM is it fits into the Ansys world, from both a sales and a support standpoint, and from a technical standpoint, which has been for a little while now. So we're just excited about it, and can't wait to learn more. Any parting questions or comments anybody would like to make before we wrap it up?
No, Eric, I just want to thank you. This was a lot of fun.
It is fun. It's good to talk to you. It's been we usually get together at least twice a year at various Ansys events, and because of COVID, that didn't happen this year. So I look forward to maybe in the summer we'll be able to see each other again face to face. And it's great to see you, Ahmad. Yeah.
Likewise.
Hope so, and the same here, Eric. As we said, we are excited to start this partnership, and also, of course, to interact with Ansys Direct, and of course PADT on that as a key channel partner. And particles are everywhere, I will say. And as we said, Eric, around 90% of what is around you today, at these in your office, they were in particulate form during a certain stage of the production phase. And just now we are being able to model that. So it's exciting, times, and with the advances of the hardware and the GPU technology, which is relevant, which makes very accessible to a low cost, solve a large particle count problem. It's enabling us to tackle all this diversity that we are seeing and discussing today. So it's a pleasure to have a chance to give you an overview, a fast one about what we can do and what we should be doing together from now on. Thanks a lot.
I really appreciate it. I've learned a ton and have a ton more questions, but what we'll do is get a little bit more experience with it ourselves, and then we'll hopefully have you guys back on a couple of releases down the road and learn what's new as well as other things we should know. So I'm psyched. And you're right, particles are everywhere. Now we can model them. So that's cool.
Super.
Take care.
All right. Thanks, guys. I really appreciate your time. We'll talk to you soon. Stay safe out there.
Thank you. You too.
All right.
Bye-bye.
Bye.
Bye.
I do want to apologize for taking so long and getting this out. As I said, we recorded a bunch of more things that had kind of time deadlines on them, and didn't get a chance to get this out till now. It's a very powerful tool. We're coming up with new and different ways of using it. It's helping us expand our thoughts on what can be simulated. And if you think it might even be slightly useful, reach out to whoever you get your Ansys from, because they're an Ansys partner now, and anybody that sells Ansys can sell Rocky DEM, and ask them for more information. So for our commercial today, instead of promoting PADT in this episode, I wanted to talk about it's sort of a charity that we've been supporting here at PADT for a long time. It's called Kiva.org, and it's a microloan site. I thought of them when we were trying to think of things we can do to help out in these places where the pandemic is really still growing and still causing a major economic havoc. And microloans to small groups or individuals is a great option to help them now and in the future. It's not a donation. You give your money to the organization, and they work with local microloan groups to give money to entrepreneurs to help grow their business. It may be buying a new motorcycle if they're a motorcycle taxi. It may be buying more chickens if they're a chicken farmer. It could be inventory for a store in the village. It could be somebody in a city who wants to add more plumbing in their neighborhood, and that's all. The uses and the applications and the industries are everywhere, and we're talking small dollars here. PADT has invested $3,000 over 14 years. That's it, and that $3,000 has been loaned out over and over again to a total of $12,125. And that's been across 138 different organizations or people in 64 different countries. We've only lost $104 that wasn't paid back in that whole time of 14 years. So your money gets used over and over again. So go to Kiva.org and check it out. A few $100s goes a long way to help people recover. And because it's a loan that usually does get repaid, it will continue to help them long into the future. So it's a simple way that you can put your money to help these places out now and in the future. And if you want to know more about our loans at PADT that we've done, you can go to kiva.org/lender/PADTINC. So that's our page there. You can see who we've given money to over the years. So let's move on to news and look at the Ansys stock price. I'm recording this, like I said, on Sunday, May 2nd. So when the market closed on April 30th, Ansys was at $365.66. That's up a bit. It was 0.5% year to date, but much better than they were at the beginning of March when they were down quite a bit, but not quite as good as they were at the mid-February when they were set an all-time high. So in comparison, the S&P 500 is up 12%. So Ansys is underperforming what the S&P 500 is doing. So why is that? As I will always say when we talk about the stock, I have no idea. Maybe we'll find out a little bit more. The earnings call will be on May 6th, and we'll go over that call in our next podcast. So let's see if that gets some attention at Wall Street. Who knows? There's no real Ansys news out there because they are in a quiet period between the end of the quarter and the release of their numbers, so they don't talk about much. No news releases from them. And being a privately held company, we can talk about anything we want here at PADT, but we don't have any new news. So I got nothing to add from PADT's perspective. let's move on to publications. The Ansys blog is, they really, I mentioned this in the last couple of podcasts, but if you haven't checked it out in a while, they've really upgraded the interface. Really cool stuff, and they're publishing more. The two articles that I really liked were, and yes, I picked it because there's a pun in the title, but it's also a good article called Wired for Success, Ansys HFSS Leads in Wire Bond Simulation. It's useful for understanding how to model the crosstalk and performance issues in wire bonds from an electronics packaging standpoint using high-frequency simulation, electromagnetic simulation. There's also and the other one I want to point out for the last 2 weeks is a post about something new at Ansys, and it was called Technology Partner Day. And this is when all of the Ansys technology partners, so people who provide platforms for Ansys to run on, tools for Ansys to be written in, as well as linked to, and then also kind of third-party tools like Rocky DEM that work with Ansys. Flonex, which PADT distributes in North America, is a partner. Ansys Motion is a partner product. MotorCAD is a partner product, and like I said, Rocky DEM as well. They're all great examples. So if you want to learn more about the partner program, check out the post to learn about it. And they gave some awards to some companies for their integration and cooperation with Ansys. For our blog, I published a post called Project Management for Nonlinear Dynamic Simulation with Ansys LS-DYNA. And it's about what the title says, how to manage projects when you're doing simulation with LS-DYNA. And it is different. If you're used to doing FEA or CFD, the project management requirements are a bit different for doing these kind of nonlinear dynamic simulations using the tool. So if you're outsourcing LS-DYNA work, or if you're doing a lot of it in-house, please do read the article. I think you'll find it very useful. In the event world, we have 2 webinars scheduled for this month, because it's now May. The first one is going to be on the 5th, and it's electronic reliability updates. So this is going to be the Sherlock tool set, so that'll be very interesting to see. And then in keeping in the area of electronics, we're going to do signal and power integrity updates for 2020 R1 on the 19th. So 2020 R1 for electronics reliability on the 5th, and for signal and power integrity on the 19th. The only other event that I have on the calendar right now for May, and I probably need to update the calendar, is on a Sunday, actually the 16th, and this is not Ansys related, but just cool anyway. It's the International Day of Light. If you're here in Arizona, there's quite a bit of a celebration, a virtual celebration that's being coordinated by the Flandau Science Center and Planetarium down at the University of Arizona, and a group that is part of the Tech Council called Optics Valley. So I look forward to taking part in that, learning more about photonics and optics and astronomy and all sorts of cool things, the science of light. So do look in your location to see anything going on. Maybe some stargazing, maybe some local shows or events. And that is pretty much what I have for today. So I want to thank everybody for listening once again. Don't forget to subscribe to the podcast at whatever service you use to get your podcasts, and spread the word about our little audio endeavor here. And don't forget to subscribe to PADT's newsletter at www.pdtinc.com/opt-in. And as always, please don't hesitate to reach out. I want to thank you once again, and hope to talk to you virtually again. Thank you for joining us for the All Things Ansys podcast, episode 87. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people in the show only, and none of their current or former employers. For more information, visit www.pdtinc.com/blog, and please share your thoughts and questions through an email to podcast@pdtinc.com. See you next time.